Hi, I'm Bill Vales, and I'm here with Dr. Electricity, Tom Vales, for another edition of Fun with Science. Tom, thanks for being here with us. Our last show was really something. I see you've brought today, we have kind of a potpourri of things here.
Not all of them are hardcore science, but they're neat.
Okay.
Different things.
Okay. You know, I'm attracted to this gizmo here. That's not a good scientific designation, but can you explain what this is here?
Yeah, about 20 or so years ago, I was visiting a friend of mine, and I saw one of his wedding presents, and it was something similar to this, that much more refined. And I thought, what a neat thing to make. So I started just thinking about it. It really has no function other than, well, you'll see what it does. But it's just one of those things that you go to make to see if you can make it, and it's neat, and it does gather a lot of attention. It is an interactive piece of electronic art, and, well, I'll demonstrate it. I'll turn it on here and here, and if I clap my hands, you can see there's two.
Light came on here.
And out there.
And a light came on here.
Now we're going to do it again. So now we've got flashing lights and the antenna going around.
Okay, there's a bunch of gears going here. The antenna's spinning around.
And we do it again, and we have different flashing lights.
More lights going on.
Yep. And that's it. That's all it does. But it's neat. And it's one of those things that I just, you know, there's no plans, there's no anything to this. It was just design on the fly, so to speak.
How long did something like this
over the course of a couple months.
Couple months.
Yeah.
I have to try it.
Well, there's one. Yeah.
Okay, the lights are on.
Yeah. Yep.
Is the antenna going around?
Now you change the flashing
Different lights.
One there and one there.
One here.
There it is.
Now it's stopped.
So it's a piece of interactive electronic art.
Electronic art.
Whimsical. It was just built to build it.
I've always seen this in your lab, and it really looks quite intricate.
Oh, well, that's another part of it.
Oh, what's that?
The circuitry that runs it, okay? The amplifier that allows the speaker to, you know, put out sound. The clap activation, you know, that switches back and forth.
Yep.
That's another integrated circuit in here.
Okay.
And then there's the components, you know, resistors, diodes, and relays, and so on. However, a lot of these components in here are fake. In other words, they don't have anything at all to do with the circuit. Okay? And if you want to talk about hanging yourself, when you're wiring something like this, you have to remember exactly where you left off and what it was you were doing. Because, you know, you can imagine trying to troubleshoot something that doesn't require troubleshooting.
So you added these extra parts just as artistic.
Yeah. Yep.
Make it
Yep.
look good.
Yep.
That's neat.
Yeah, there you go. You got the lights on. Oh, hit it again. Yeah.
Okay. Great. Okay, that's really interesting. Let's look at a few of the other things you have
Slide
here.
it down.
Okay, here we go. And let's
All right.
I have to say, and that's a work of art too. I mean, symmetry, the design, the machining.
It's fun
It
stuff.
all looks
All right, what do
nice.
you want to go with next here?
Okay, let's go with this. Let's go with this. What do you have here?
All right. This is called a kaleidoscope. And I'm sure many people out there have had them or have them or collect them. They're a grouping of mirrors in a tube, and you have your objects at the end, and light comes in the end, you know, goes through, lights up the objects. And then when you look through the eyepiece, you can see these patterns. As you turn it, the patterns shift as the stuff in the sample box changes.
Yep.
Well, this is a kaleidoscope, and if you notice, here's where you look. This is where you turn the sample chamber. But there is no aperture on that kaleidoscope for light. There is no...
I'm seeing some great patterns here. I mean, beautiful arrangements in pastels.
Yep.
But you said there's no light. You're right, there is no light.
There is no light. Nope. It's a self-illuminated kaleidoscope.
Self-illuminating.
No batteries, no LEDs,
Yep.
no light bulbs. Nope.
What's causing the illumination?
Well, actually, it's radioactivity. They're little tubes that are filled with tritium gas, which is an isotope of hydrogen, and a phosphor.
Okay.
And they glow. And where do you see them? You see them on wristwatches, you see them on gun sights, you see them on exit signs. They glow 24/7. And about 10 or so years ago, I was thinking, geez, I wonder if I could make a kaleidoscope that didn't need light. Well, I got going on this, and I made 6 kaleidoscopes, and all different types of mirrors. This one here has 3 mirrors, which is typical. Okay, that's typical kaleidoscope for a kid. 3 mirrors, 60 degrees, and you get all those, you know, those triangular images.
Yeah, it's beautiful.
But what's different on this is that it is 3 mirrors, but they're tapered, so that they start out big and they get small. And what that does is that gives the appearance on the eyepiece of a hemisphere, of a circular pattern. And this is good for another 20, 25 years before the tritium.
Well, I was going to ask you, I mean, this isn't good forever.
No, it isn't.
Right. Because it
And
has
what's-
a half-life?
Yep. What's even funnier is when I leave them on my bench and I come in at night and I'm sitting there and my eyes get dark adjusted, there's shafts of light coming out of these kaleidoscopes.
Oh, wow.
It's kind of weird.
Wow. Well, not weird in your lab.
Nope.
Has anyone else built these?
Not that I know of.
Okay.
Yeah, this was
Well,
just something.
I mean, beautifully machined. The wood is
yeah, that's
beautiful.
oak. That's oak. This is Cocobolo.
Cocobolo.
This is tellurium copper. And this, believe it or not, is a piece of PVC drain pipe that I came up with a formula that if you can buy spray cans of paint,
Yeah.
that will give you a mottled appearance.
Yeah, yeah.
Well, I did that and I got some clear sealer and I sprayed
nice.
I sprayed the stuff on there and then I put the sealer on it, which made it even, you know, better.
How long did it take you to make this?
That was probably at least a month.
Yeah. Wow.
Because there was some pretty intensive stuff, having to cut the glass. And here's a little trivia for you folks. A kaleidoscope has mirrors. You stand in front of a mirror when you get dressed or whatever to go to work. But the difference between the mirror that you stand in front of and the type of mirror that's in a kaleidoscope is this. The mirror that you stand in front of is a thickness of glass. Light comes down, hits the glass. When it bends a little, hits the mirror, then comes off the mirror to the glass. When it goes back to the air, it bends a little going the other way. that produces a distortion.
Okay.
You don't even see it.
Okay.
You don't see it.
Okay.
That would see it. So what these use is first surface mirrors. In other words, the silvering is on the top of the glass, not on the back. So you have to be very careful handling first surface mirrors because you can scratch them.
Interesting. You know, as I look down on this, I can see, are they scintillations?
No.
No?
No, there's nothing radioactive in there.
Okay. Well, there is.
Oh, well, yeah, sorry,
There's tritium.
I forgot. But the tritium, you could put it in front of a Geiger
Okay.
counter and you wouldn't even register it.
Okay, well, that's comforting to know
No,
after
it
I had
is.
my eye on that.
Well, that's all right.
Well-
You did say you need cataract surgery, right?
That's true.
I give up the...
So since we're talking about light, this seems like a natural
Segue?
segue into this device here, or whatever object here. What do you have here? What is this? And that's
Okay.
fairly heavy.
This is called a fiber optic taper, okay? It is made up of many, many glass fibers and is pressed or formed into this shape, okay? So that whatever you have up here in terms of the fiber optics, you have down here.
Okay.
All right. Things obviously down here are getting a little tighter than they are up here because
Yes,
you've cut
yeah,
your
sure.
by half. So how do you want to show this?
Let's try this. Here we have a $10 bill. And we're going to show this
See, oh, there he is. Okay.
with Mr. Hamilton right on top. Okay.
Now, you notice that that image is right on the face of that taper.
It is.
It is not down below.
Right.
It brings it right up.
Right, it's right there.
And it magnifies.
Yes, yeah, that's absolutely magnified.
Yep.
Okay, so now I'm going to turn this over, put it on Mr.
Hamilton.
Hamilton, and now we see
He's,
a smaller Mr.
Yep.
Hamilton. Now, both images are in scale. I mean, neither is distorted.
no.
Neither is distorted.
No, neither's distorted or neither is got a problem, you know. But you notice that the image there is right up at the end of the taper,
It is.
and it's reduced in size.
It's reduced in size.
I don't know what the use was that the government, this is a government thing, what the government used it for, okay? It could be anything. It could be a bomb site. It could be all manner of optical stuff that they're doing,
Yep.
because you
Yep.
just don't know. But here's the thing that I want to leave you folks with about this. The images that we saw were perfect. Perfect.
They were.
Changed in size, but they were perfect. I don't know how many tens or hundreds of thousands of glass fibers are on this end, but I know this. Whatever is here is down here, and it's in perfect order. How did they do that?
How did they do that?
That's, you know,
It's amazing. Well, that's your tax dollars at work there.
yep,
So,
that's right. Yeah,
okay.
see, your textiles are shrinking already.
Okay. All right. Okay, let's look at this device here. What do we have here, Tom?
This was made by Westinghouse Corporation in 1931. For lack of a better word, it's called a touch switch.
Touch switch.
All of those of you out there that have lamps you can touch, they come on and get brighter and then shut off, and you thought this was something new. Well, it isn't. Different components, you know, obviously a larger size, but back in 1931, they had this thing. And this globe is the antenna electrode. You could run wires, long wires, to plates. And what this was used for example, in like the store window, a manufacturer wants to show you a dozen different floor lamps. But he doesn't want to have them all in a row. They take up too much room. So what does he do? He builds a platform. And much like the Tesla Lazy Susan, and puts the lamps on it, and then has a plate on the wall in front of the window that has, if you want to see, you know, the display, touch your hand and take it away. And that would turn on the motor and the thing would go to the next lamp.
So this can be used to actuate something.
Yeah, this. Oh, let's see.
Okay.
This-
Now, I don't know if you can hear it, but there's a sound. You can hear this switching, a relay going.
Yeah, that's a relay that
As you
would
touch this,
activate your device.
On, off,
Yeah.
on, off. Now, if you've ever seen these lamps, I've seen them on late night television that you can just touch and they'll go on, you know, without turning the switch.
Right.
That is this technology in 1931.
Right.
Okay.
And the thing that switches this is this tube that you can see, or maybe, I don't know if you can see, yes. It was called a grid glow tube, which was their, you know, their sound bite for it, so to speak. But it has neon gas in it. That's where the orange color comes from.
Okay.
And it acts as a switch. When you put your hand on the thing, you trigger that, and that turns on the relay, and then you're off to the races.
Neon, one of our elements.
Yep.
Noble gas.
Yep.
Okay. Inert. I want to point out that this, as you said, is made by Westinghouse.
Yep.
And look at that. I just touch this and it comes on.
Well,
And what was the connection of Tesla to Westinghouse?
well, George Westinghouse was a friend of Tesla's. He backed him in a lot of his things. He was working with him to help electrify Niagara Falls. He was also involved with him. Westinghouse got the contract to illuminate the 1893 Columbian Exposition. And he was a good friend of but here's another little trivia tidbit. George Westinghouse did not make his money initially on electricity. He made it on air brakes for trains. Because prior to that, if there was a problem with a train losing its brakes, which they did quite regularly, many people get killed.
Yeah.
So Westinghouse came out with air brakes.
I see. I see.
No, that's just being...
Okay, that's interesting. New technology that isn't as new
As you think it
as
was,
we
yeah.
thought. Okay, let's work our way through
All right.
here. What's
Yeah,
the-
I know, I got to get that because I'm going to
Okay.
lose.
Okay. We have another item here that I'd like to show the audience. Okay, I'd like you to talk about what this is, Tom.
Well, before the atomic bomb could be built, the scientists had to verify that a radioactive chain reaction would happen.
Okay.
That didn't happen, there was no point in building the bomb.
Okay.
University of Chicago, Stagg Field, under the auspices of Enrico Fermi, the first chain reaction nuclear device was built.
Okay.
And once that was built, that told them out at Oppenheimer, out on the Manhattan Project, that go ahead and build the bomb.
Okay.
And this is a piece of graphite that was part of the reactor's core.
Okay.
And the graphite isn't radioactive.
Okay.
It acts as a moderator.
Moderator.
really.
So that would slow down the
Yeah,
neutrons?
slow them down a bit.
Okay.
But the it's not radioactive.
Okay.
It's just a piece of history. I
Okay.
mean, it is
So this
quite-
is 1942.
Yeah, right around in there.
Okay, when we were at war.
Yep.
And building the bomb. So this was an integral piece of work and theory that
If that didn't work,
if that didn't work, you
forget
couldn't
it. All
build it.
bets are off.
Okay. And Enrico Fermi, he won a Nobel
Yeah,
Prize, I
He's an
think.
incredible guy.
Yeah, and I think there's also a element named
Fermium.
after him, which, from what I've read, having an element named after you is really almost a pinnacle for these people that
Oh, it's better than a Nobel Prize.
it's better than a Nobel Prize. So
So that
okay,
was an
so
interesting
that's
thing.
great.
All right.
I wanna
What
ask
are we
you-
going to next?
Okay, this looks interesting. This little ring is what it looks like.
Looks like a bomb.
Yep, it looks like a bomb. That's great.
And it has a
Here we go,
Yeah.
little ring.
has a red tail section.
Okay, tail section.
Well, this ring is quite unique, and it has quite a history. It was put out as a prize or something you would send away for in Tick cereal, 1947.
Tix cereal.
Tix cereal.
Okay.
15 cents and the proof of purchase would get you one of these. Now, what exactly is this? Well, it's a little more than most of you are going to ever imagine. What they did was they put a small amount of polonium-210, which is a radioactive substance, in the end of this silver part. Then there was a plastic screen that had zinc sulfide and activated zinc sulfide on it. And then there was a little lens. And what you would do is you would take it into the bedroom and you'd get under the covers and you'd get your eyes dark adjusted. Then you'd take that red tail section off and look in there, and you could see these flashes of light. And what those flashes were was the scintillations caused by the alpha particles leaving the plutonium hitting the zinc sulfide.
Wow, fun with polonium-210. That's great.
Yeah.
So polonium is a radioactive
Yes,
element. It's got various isotopes
Oh, yeah,
associated
yeah,
with
yeah.
it. What's the half-life of this? We looked it up before.
Yeah, I know.
About 100
Oh, wait a minute, 138 days.
138 days, okay.
So any of these that you find now are dead. And
Well-
if they're not dead, they've been doctored with.
Okay, okay.
I'm going to try to
Okay.
resurrect that one.
All right. Well, that's good to know. 138-day half-life. Yeah, I'm sure this is something that parents wouldn't be flocking to today in their Wheaties or anything. So that's really interesting. Polonium-210.
Yep.
That's great.
Yep. Little, you know, and I can remember,
the bulb here.
I can
To
remember,
cleanse myself.
here we go.
What do we have here, Tom?
We have what's called a Mercury Puzzle. It's a maze. I don't know what, see if you can tip it. Look at the monitor. See if you
Okay.
can tip it so that he can,
Okay, okay. Okay, so you see the mercury
yeah.
down
Okay.
the bottom.
Yep, and there's the maze.
Okay, there's the maze. There's a maze here.
The object,
The idea
yeah, is to get into the maze
into the maze.
and then move it around and get to the center. But what you will find out really fast is that mercury, I mean, it has a fairly low coefficient of friction, and it tends to want to go. Oh, there.
Whoa.
Oh, you got part of it in there.
Look at that. Okay.
When I was a kid, there were mercury mazes you could buy. One was a blue and one was red. They were about 4 inches square, about 3/8 of an inch high. They had a maze integral with the bottom and a big glob of mercury. And, you know, that was neat. That was a lot of fun. You know, you know, I showed it to my father, and of course he just, oh God,
Yeah, I can attest to that.
what's he doing now?
Um,
But
This is interesting.
But today, well, mercury can be dangerous if it's not handled properly, okay? Not to make light of it. The Japanese found this out back in the 50s, I think it was, that they were running industrial plants and they were dumping the waste in the ocean, and the waste happened to have mercury in it, in one of its chlorides or whatever. Fish would absorb the mercury. Then they'd go and they'd catch the fish and eat the fish, and
Yeah.
mercury poisoning is not one of the better ways to go.
And it's a cumulative
Oh, yeah.
effect
Oh,
with
yeah.
heavy metals, so it's not like if you ingested some mercury and then you waited 10 years before you ingested more, you're okay. It's a cumulative effect.
Yeah, and
I've done pretty well here. I hope Mark has recorded this,
he,
because I've actually I've scored pretty high here.
the Japanese, I mean, the things that you would
Yep.
have would be tremors, headaches, blindness, you know, nerve damage, and
Well, I'm
So
thrilled that
we're-
I'm protected by this
There you go.
plastic case.
there you go.
Okay. Well, we have one more object of interest here, and isn't this interesting? Let's look at this. This is a Coke bottle, classic Coke bottle with an arrow through it, and the arrow is definitely through it. This is a vintage Coke bottle.
Yep.
So what went on here with your idle time?
Well, I said, geez, it'd be nice to make this particular puzzle, so I bought a Coke bottle on eBay. I drilled 2 holes in the Coke bottle with a diamond hole saw.
Okay, so that in itself is difficult, I would think.
Well, you don't want to crack the glass. That's
Yeah.
the problem there. Then I got some pine, and I made the arrow. Okay, made the arrow.
Okay, but the arrow doesn't fit.
Well, then I got a tea kettle going, and I got it good and hot, and I put the head in the steam, and I got it saturated with hot water, okay? Then took the head and put it in a vise and squeezed it, because now it's very pliable. Squeezed it down so it was the same diameter as the shaft, shoved it in a Coke bottle, and then went and steamed it again, and it popped out, and I sanded it, and that was it. End
Wow.
of story.
Wow.
Yeah, it's just a neat puzzle.
Neat.
You know, everybody says, oh, it's screwed together, it's glued together, it's got nails,
It's not. It's one piece of wood. It's
Puzzles are great things.
yeah.
Puzzles
It's
are
really
great things.
interesting. Well, this has really been interesting. This is kind of a potpourri of stuff that you have. This really just scratches the surface. So I know, you'll be back with more stuff. But I want to thank you for
All right.
coming here and
Yep.
sharing these things. I hope you, the audience, have enjoyed this Fun with Science, kind of a fun collection of tools and objects and projects. And we'll look for you next time on Fun with Science. Thanks a lot.